All right, get ready to dive into something, a real scientific paradox, I guess you could say.
Yeah.
It's called the Mpemba effect.
The Mpemba effect.
You with me on this one?
Oh, yeah, I am. It's a fascinating one.
Have you heard about this?
I have.
Okay, so basically it's like this, you know how like we expect things to cool down gradually? Well, the Mpemba effect kind of throws that idea right out the window.
It does. It does.
And it says sometimes hot water actually freezes faster than cold water.
You got it.
So imagine two containers, right?
Okay.
One filled with steaming hot water, the other one ice cold.
Right.
You put them both in the freezer.
Yep.
Which one do you think is going to freeze first?
Common sense would say the cold one.
Exactly.
Right.
But sometimes the hot one wins.
It's true. Sometimes it does.
So what's going on here?
Right. That's the big question, right?
Yeah.
Well, it's not a new thing.
Okay.
I mean, people have been noticing this kind of thing for centuries. Even Aristotle wrote about it.
Wow.
But it was a Tanzanian student, Erasto Mpemba, who really kind of brought it to the world's attention back in the 1960s.
So a student in the 1960s.
Yeah, so, it's been around for a while.
It wasn't like a scientist in a lab coat.
Right, exactly.
Yeah.
It was, just somebody observing the world around him.
And it sparked this whole...
And going, that's odd.
Yeah.
That doesn't make sense.
Scientific mystery.
That's right. That's right.
So what do they think is going on?
Yeah, so there are a bunch of factors that are being investigated.
Okay.
5 main ones that scientists are really looking into right now.
Okay, well, let's...
To try to get to the bottom of this.
Let's start with one that seems maybe the most obvious to me.
Yeah.
Which is evaporation.
Okay.
Right.
Okay.
So you've got a pot of water on the stove, boiling. You can see the steam.
The steam is coming up.
Rising, right.
Yeah, you got it.
That's water.
That's water evaporating.
Going into the air, disappearing.
It's literally going poof into the air.
Yeah. So that means
Yeah.
if you're starting with a certain amount of hot water,
Right.
some of it will be gone
Yeah,
before it even gets a chance to cool down.
that is true.
So there's less water
Less water.
to freeze, which would
Less water to freeze?
make sense that it would freeze faster.
Or logically.
But you're going to tell me it's not that simple,
Well, yeah.
are you?
It's science, so it's never that simple.
Okay, all right.
But even when scientists, control for that, like when they do experiments where they account for evaporation,
Right.
they still sometimes see this Mpemba effect happening.
Wow.
So evaporation is part of it,
Yeah.
but it's not the whole story.
Okay. Okay.
Can't explain it all.
So that's where it gets interesting.
That's where it gets really interesting.
What else is going on?
Yeah, well, what about these things called convection currents?
Convection current.
Yeah, have you ever noticed, when you're boiling water,
Yeah.
it's not just sitting there in the pot.
Right.
You see these, rolling bubbles in movement.
Yeah.
It's like infection. It is. It is the hotter water's rising.
Right.
The cooler water's sinking. It creates this, cycle.
I remember learning about that in school.
Yeah. And these currents, they're much stronger in hot water than they are in cold water.
Okay.
And this could actually, help speed up the process of heat transfer. It could be helping the heat get away from the water faster.
So even though the water is hotter,
Yeah.
it might actually be better at
It might be better at getting rid of its heat.
getting rid of that heat. Yeah.
Exactly.
Because of all that movement.
Yeah, think of it like you're trying to cool down 2 pots of soup.
Okay.
One you just leave sitting there.
Okay.
One you stir constantly.
Yeah.
Which one's going to cool down faster?
The one you stir.
Right.
Yeah, okay.
Because you're helping the heat escape.
Interesting.
Right.
Okay.
Does that make sense?
That makes sense.
Yeah.
What about the supercooling thing?
Supercooling. That's where things get a little more complex.
Okay.
So basically, for water to freeze,
Yeah.
it needs a kind of a seed.
A seed?
Yeah, something like a little dust particle or even a tiny ice crystal
Okay.
to start the process of forming a solid structure.
Oh, so it needs
It needs a little something to grab onto.
be like, okay, now we're ice.
Right, okay, time to become ice now.
Yeah.
And sometimes, especially with very pure water,
Okay.
cold water can actually get stuck in a liquid state
Oh, wow.
below its freezing point
Because
it doesn't have any of those seats.
too clean.
Yeah, it's too pure.
Wow.
It's it's hesitant to change. It doesn't know what to do.
Fascinating.
So that's called supercooling.
So it's like...
So it's almost like it's too pure to freeze, you know?
Yeah. Yeah, it doesn't know how to...
Yeah, exactly.
It needs an example.
Right. And the thinking is that hot water might be less likely to supercool
No.
than cold water.
So it just goes for it.
It just goes for it. Yeah, it's possible that that higher energy state prevents it from getting stuck in that supercooled state, you know?
So while the cold water is waiting around for a signal,
Right.
the hot water is just like, I'm becoming ice.
Yeah, exactly. Like, I'm going for it.
Interesting. Okay.
So we've got evaporation, we've got convection currents, we've got supercooling.
What else?
Let's talk about dissolved gases.
Okay.
Have you ever noticed how a cold soda
Well, yeah.
goes flat much faster when it warms up?
All the time.
Yeah.
Happens all the time.
Yeah, it's because warmer liquids, they can't hold as much dissolved gas.
Yeah.
Right.
That's right.
So it turns out that cold water can hold more dissolved gas than hot water.
Okay, so is the idea that that's somehow slowing down the freezing process?
That's what scientists are trying to figure out.
The gases?
Yeah, like, do those extra gases in the cold water, are they somehow messing with the freezing process?
Okay.
It's another piece of the puzzle
So we got
that they're actively looking into.
evaporation,
Convection
currents,
supercooling,
dissolved gases.
Dissolved gases.
All right.
Yeah.
This is already...
It's complex, isn't it?
Yeah, pretty complex.
Yeah, lots going on here.
I'm glad we have you here to break it down for us.
Well, I'm trying. We'll see.
Yeah.
It's fascinating stuff, though.
It is. It is.
Yeah, it's a lot to think about, isn't it?
It is. It is.
And the thing is, like, even with all of this, even with all these factors we've talked about, there's still a lot we don't know about the Mpemba effect.
Really? So even after all this research?
Oh, yeah.
It's still an unsolved mystery.
It's still a bit of a mystery, yeah.
Wow, I love that.
Yeah.
That's what makes science fun.
It does. It's those unanswered questions that keep us going.
Yeah,
keep us pushing the boundaries of knowledge.
I like that.
That's what science is all about.
Yeah.
So that brings us to the fifth.
Okay.
And perhaps most intriguing factor of all.
All right.
The ongoing mystery.
The ongoing mystery. I love it.
The fact that we still don't have all the answers.
It's inspiring to think about.
It is.
This student, Erasto Mpemba, back in the 1960s.
He had the courage to challenge what everyone thought they knew.
He just saw something.
He did.
I was like...
He was making ice cream.
Yeah.
And he noticed his hot ice cream mix was freezing faster than his classmates' cold mix. And he's like, why?
Instead of just shrugging it off.
Yeah. And some adults even dismissed him.
Yeah.
But he persisted.
That's good.
He kept asking questions. And that's what led to this whole exploration.
It's amazing.
It is.
To think that just being curious...
It's a testament to his curiosity.
And asking questions.
And his persistence.
Can lead to, who knows what.
Absolutely.
Real breakthroughs.
And it's a great reminder that scientific breakthroughs can come from anyone, anywhere.
It really highlights the importance of encouraging that kind of thinking.
It does, fostering that sense of wonder and encouraging people to question what they observe.
Yeah.
Because you never know where the next big discovery is going to come from.
What if he had just, shrugged it off?
Right, exactly.
Who knows?
We might not even be talking about this right now.
You might not. We might not. It makes you wonder.
It does.
Are there other things out there that people have just kind of dismissed as, oh, that's weird?
Yeah, that's strange, whatever.
Yeah, and not really thought about it.
And not dug deeper.
Yeah.
Yeah, absolutely.
Speaking of digging deeper, I'm curious about any real-world applications for this.
Oh, that's a great question.
Is there anything, could we actually use...
Yeah, that's what everybody wants to know.
Right.
Like, what's the point of all this?
Yeah.
Well, it's still early stages.
Okay.
But researchers are actually looking into how the principles behind this Mpemba effect could be applied in different fields.
Like what? Give me some examples.
Well, for instance, there's research into how it could be used to improve cooling systems. Making them more efficient.
So, like, industrial cooling systems.
Yeah, exactly. So if we can figure out ways to make things cool down faster, it could have a huge impact on energy consumption.
So like make our freezers better.
Yeah, exactly. Things like that.
Yeah.
Researchers are also looking into its potential in food preservation.
Oh, okay.
Imagine being able to freeze foods more quickly.
Right.
It could lead to better preservation of nutrients and flavor.
So instead of...
There was a paper I was reading recently where they were experimenting with using the Mpemba effect principles to freeze fruits and vegetables.
So understanding this weird thing could actually have some real-world benefits.
Real-world benefits, exactly.
It's amazing
to
think how this simple observation about hot and cold water
Yeah.
can lead us down this
rabbit hole.
This rabbit hole
Yeah.
of scientific inquiry.
It really shows you how much we still don't know.
It does.
About the world around us.
It does. Even something as simple as water.
It's humbling, in a way.
It is. It is. And that's what makes science so captivating, right?
Yeah.
It's this continuous exploration and questioning of what we think we know.
Yeah. Yeah, that's what keeps us going.
Keeps us on our toes.
Keeps us on our toes.
Before we move on, though,
yeah,
I think it's important to emphasize one thing for our listeners.
Right.
This Mpemba effect, it's not something that happens consistently.
Right.
Or predictably every single time.
You can't just stick a pot.
Right. You can't just, like...
Of boiling water.
Take your boiling pasta water.
Yeah. And throw it in the freezer.
And expect it to.
And expect it to magically freeze faster.
Yeah.
Than a glass of cold water.
Every time. Yeah.
Every time, right.
Right, right.
There are specific conditions.
It's not a magic trick.
It's not a magic trick, yeah. It's a complex interplay of factors.
Yeah, yeah. We've talked about a few of them.
And who knows what else is going on?
So
we haven't even thought of yet.
While it's fun to think about,
yeah,
we should be cautious
about
making assumptions.
Yeah, yeah. Thinking we know it all.
Exactly.
Because we don't.
Because we don't. Science is all about nuance.
Yeah.
Careful observation.
Yeah.
And rigorous testing.
Rigorous testing. I love it.
Yeah.
It's been a fascinating conversation.
It has.
It has.
It's a fun one to talk about.
It really is. I feel like I'm looking at the world around me.
No, right?
In a whole new way.
It makes you think about things differently.
Yeah.
Like, even just going to the freezer now.
I'm going to be thinking about the Mpemba effect.
I know, me too.
It's going to be in the back of my mind.
It's going to be in the back of my mind.
Every time I open that freezer door.
Every time. Every time. You know, it's funny to think about this whole thing.
Yeah.
It all started with ice cream.
Ice cream, right?
Remember we were saying that Erasto Mpemba?
Yeah.
He noticed this.
Yeah, he was making ice cream.
When he was making ice cream.
That's how he noticed it.
Yeah.
His hot ice cream mix was freezing faster than his classmates' colder mixes.
It's amazing to think that.
It's crazy, right?
A sweet treat like that.
I know.
Could spark this.
Could spark a scientific debate.
Scientific debate.
That's still going on today.
Yeah, yeah.
It's pretty wild.
It makes you think about just staying curious.
Yeah.
You never know what you're going to
find.
See, that's going to lead you down this
rabbit hole.
This rabbit hole, yeah.
Yeah, it's hard.
It reminds me of that.
It's like that Louis Pasteur quote.
Yeah, chance favors the prepared mind.
Yeah, you got to be ready.
Got to be ready to see it.
To notice the unusual.
Exactly.
Even in the everyday.
Even in the everyday stuff, the stuff we take for granted.
And not be afraid to ask questions.
Yeah, don't be afraid to ask.
Even if they seem kind of silly.
Especially the silly ones.
Yeah.
Those are usually the best ones.
I mean, think about if he hadn't asked that question.
Right, exactly.
About his ice cream mix.
We might not even be talking about this right now.
Yeah.
Who knows?
We might not even know about the Mpemba effect.
Yeah, it's crazy. Hidden relationships in the natural world.
Exactly.
That we just haven't
stumbled upon yet.
Yeah.
So much we don't know.
All right, well, before we wrap up.
Yeah.
I want to leave our listeners with a challenge here.
Okay, I like this.
So, we've talked about those 5 main factors.
5 main factors.
That scientists are looking into.
That they think are at play.
But what if there's something else?
What if there's something else going on?
Something that we haven't even considered.
That we haven't even thought of.
So, to everyone listening out there.
Put on your thinking caps.
Put on your thinking caps. What if you were a scientist studying this?
Yeah. What questions would you ask?
What other questions would you ask?
What experiments would you design?
Yeah.
It's a great question to ponder.
Who knows?
Who knows? Maybe one of our listeners will be the one to crack this thing wide open.
To finally unravel the mystery of the Mpemba effect.
Yeah, the world of science is open to anyone.
That's right.
With a curious mind and a passion for exploration.
Well said. Keep those minds curious, folks.
Keep them curious.
Don't be afraid to.
Don't be afraid to challenge those assumptions.
Challenge those assumptions.
Yeah.
You never know what you're going to find.
You never know what you might discover.
All right, that's all the time we have for today.
Well, that was fun. Keep those ice cube trays full.
Keep those ice cube trays full.
You never know what you might observe.
You never know. All right, we'll see you next time.
See you later.